Recording. Okay, so now I want to demonstrate a few more very useful and helpful commands that are typically used in R to help us do multi-level analysis. I told you that computing ICC2 and RWG is something that is not very easy in SPSS. So R does provide us very simple, easy commands to compute these indices. We have already seen ICC2. How do we compute ICC1 and ICC2 in R? I will now demonstrate a few more things about managing multi-level data files in R. So I'm going to use this another R script that I had mailed all of you, which was additional commands.r. Okay, remember this file I had mailed last week, where I have specified some additional commands that we will be using. And here, if you open this file, additional commands.r, here I have put in some additional commands that you may need some or the other time in your analysis. So this file will be a go-to repository for you to look up any additional commands you may need. So here in R, there are two very useful functions, merge and aggregate. In order to prepare our data files for uh, multi-level analysis, we often use this merge and aggregate functions. Let me show you how. So let's take an example of data cohesion, which exists in this multi-level package. And if I show you what this package is, what this data file is. So this is basically, there are groups, and there are cohesion has 5 items: cohesion 01, 02, 03, 04, and 05. There are units. So 1044B is an army unit and 1044C is an army unit. Within army unit 1044B, there are two platoons, platoon first and platoon second. Similarly, within army unit 1044C, there are two platoons, first and second. Okay. Now, what is this? What is the use of this merge and aggregate function? Now, let's say we create there is a uh, another kind of data frame that I create, which I call as group.size. And what do I say? Unit has four values: 1044B, 1044B, 1044C, 1044C. Platoon has first, second. And what is the platoon size? You see, 1044B first platoon has 3 members. 1044B second platoon also has 3 members. 1044C first platoon has 2 members, and 1044C second platoon has 3 members. So I create a data frame which has unit, platoon, and platoon size 3323. Okay, so if I show you group.size, this is how the platoon size has been recorded in this data frame. Okay, now the merge function. The beauty of this merge function is it can be used to very easily combine two groups. So there was cohesion, okay, and now there is group.size. We want to combine, I want to write this platoon size in this data frame. Okay, so what is the command? I say merge. What are the two data frames? Cohesion and group.size. And what is the grouping variable? So the grouping variable in this case are two. So I say by combine unit and platoon. If there was only one, like in our previous example, there was only one GRP, so you can simply say by is equal to GRP, okay, or school code, SCH code in our education data. But here we are saying there are two grouping variables, unit and platoon. So what do I say? I say new dot cohesion and I use this command merge, and I merge these two by the grouping. So this unit and platoon, the only thing you have to ensure is that unit and platoon should be in both the data frames that you are wanting to merge. So you see unit and platoon is in cohesion and unit and platoon is in the group dot size data frame also. So when I do this, and now if I show you the new dot cohesion, you will see that just in one very simple command, the two data frames have been added and P size, platoon size, has been repeated 333 for the first platoon, 333 for the second platoon, 22 for the third platoon, and 333 for the fourth group. Right? That's the beauty and the power of this merge function. Now let me show you the power of aggregate command. Aggregate, just like in SPSS, we computed the aggregate, right? We did the aggregate. Here also you have the aggregate function. And let's say we wanted to compute the mean of CH01 and CH02. So what do I write? I say aggregate cohesion 3 all rows and columns 3 and 4. Okay, and list, what is the listing variable? The listing variable is unit and platoon. And what do you have to compute? You have to compute the mean. So list here means just like here we had by, okay, combine unit and platoon, here it is list. So what is the grouping variable? Here we have two, unit and platoon. And what do you have to do in the aggregate? You have to take the mean. So let's say I run this temp and I show you what temp is. Now you see what has happened. It has said group 1, group 2. So 1044B first, the mean of CH01 and CH02. So for both of these, let's say, so for this 4, 3 and 2, what is the mean? 3. The second 3, 4 and 3, it is 1044 C first. So 3 and 3, the mean is 3. Then 1044B second, the mean of 3, 4 and 3, 10 divided by 3 is 3.33. And 1044C second, 3, 2 and 1, the mean is 2. So I have computed the mean for both CH01 and CO group wise mean. Okay, please understand it is, let me write it here, group, so that you don't forget, it is group wise. Just like in SPSS we were doing aggregate, group wise mean of CH01 and CH02. This is what we have been able to achieve. I have been able to achieve for both these CH01 and CH02 group wise mean. I have been able to compute. But now you see CH02, it shows Na. Why? Because there was one missing element here. That is why it could not compute the mean of the 5, Na and 3. That is why it is written Na. So I replace this. I just add one more switch, Na dot remove. Remove all the missing from your computation. Na dot rm is equal to true. Now when I run this, okay, and I again see temp, it has computed the mean. So the first 1044B First, the average of CH02 was, CH02 would be average of 5 and 3, right, which is 4. Then 1044B, 1044C first. So 3, 3 and 1, right? 3 plus 1, 4 divided by 2. So the average is 2. Then 1044B second, 448 plus 311 divided by 3, it is 3.66667. And 1044C second, average of 3, 2 and 1, it is 2. So it has done group wise mean of the two. You could do it for any, okay. And now what I do is I simply change the names and I say replace the names as unit, platoon, G.ch01 and G.ch02. Okay, if you see temp, now it has become unit, platoon and group mean of COH01 and group mean of COH02. Now the final could be, you simply merge the data frame with the temp and by unit, because now you have ensured that you have the same variable names. So very simple. And now if I see final cohesion, okay, so I have now my final data frame. So I am now preparing my data for multi-level analysis. You see, I have p size, I have the group mean also, okay, and it has been repeated for all the three values, all the three members here. Okay, so this is demonstration of the merge and the aggregate function. Very, very useful. And I have picked all of these commands from this Blease data document. Okay, so you see, this is multi-level analysis, multi-level data manipulation functions, the merge function, right, on page number 10, and the aggregate function on page number 11 for your reference. I have already uploaded this. Please do look, take a look, revise this, read this, okay, and try this. Now let us come to the last one which I want to show, which is within group agreement. So we have done ICC1 and ICC2, but we need to also compute RWG. Let me share my presentation here, just take you through the three indices. RWG, grouping statistics. These are called as grouping statistics. When you do your analysis, you will typically report these three. Okay, so RWG, the rule of thumb is should be greater than 0.70. ICC1, intra-class correlation coefficient 1, how much of the variance is attributed to the higher level, calculated from a one-way ANOVA, where variable of interest is the DV and higher level entity is the IV, that means the grouping variable. And ICC1 equal to 0.12 means 12% of the variance is attributed to higher level entity. Okay, rule of thumb is up for debate. There is no rule of thumb. I had told you earlier, we don't really know what is the ideal cutoff. Okay, some people say it should be greater than 10, it should be greater than 12, but there's no real. ICC2, okay, Cronbach alpha of ICCs, just how it is called, an estimate of the reliability of group means. How confident are we in saying that the group means differ from each other? And the rule of thumb here is again should be greater than 0.70. Okay, so these three numbers you should always know how to compute. ICC1 can be computed in SPSS, but RWG and ICC2 are typically very difficult to compute in SPSS. So that is why I'm teaching you how to do it in R, so that you can complement, even if you are working in SPSS, majorly. Okay, just learn how to compute ICC2 and RWG in R, and then you can do all your analysis in. So ICC1 and ICC2, this formula we have already seen. Now there are just two more things that I want to talk about. There are two kinds of constructs or phenomena, okay, when you are thinking of averaging lower level to higher level. Just like we aggregated HRS and brought it to group level and called it as G dot HRS, right? Now there are uh, two processes. The first one is called as composition process. Composition processes are those which are based on the idea of isomorphism. That is, lower level data are assumed to be similar to each other and to higher level constructs. So, for example, team culture. So, you ask individual members to say, tell me on a scale of 1 to 5, how do you think your team culture is? Tell me on a scale of 1 to 5, how is your teamwork? How is the leadership? So, what are you doing? Even at the individual level, what are you asking? You are asking about the level 2 phenomena. So, when you aggregate, you will get level 2 phenomena, right? So, we say when you aggregate, you will get the same level 2 phenomena which was being asked at level 1 also. So the lower level data are assumed to be similar to each other and higher level constructs. Even what you were asking individuals is what you will get when you aggregate them. And when you have this kind of a process, then it is very important. You should compute and show that your RWG was greater than zero point 0.7, your ICC2 was greater than zero point 0.7, and so on. On the other hand, there are compilation processes. On the last class, I was giving you an example of gender and diversity. When you ask individual what is your gender, and then when you aggregate it, you get diversity, right? You get diversity. So the variable has changed in meaning. When you ask individual what is your socio-economic status, and when you aggregate it at the school level, you get how rich the school is. So the variable has changed, the aggregated variable has changed meaning as compared to the individual level phenomena. And therefore we say there is distinct differences between lower level disaggregated and higher level aggregated responses. Aggregated construct measures a phenomena not visible at the lower level, and therefore, please understand, similarity is not a necessary condition for aggregation. Reliability measures are irrelevant. If you are arguing that G dot HRS, for example, HRS is the number of hours a cadet works. And what is G dot HRS? G dot HRS is actually how many hours the platoon is actually functioning. So G dot HRS, the platoon functioning, is very different from individual functioning. And if that is the case, then I don't need to compute this RWG, and I don't need to show that there is within group agreement, and therefore I can aggregate. But if you are asking about leadership, everybody is saying, how is my leadership at the group level? How is the teamwork at the group level? How is the culture at the group level? So at the individual level also you are asking about culture, about teamwork, about leadership. And therefore we must show that there is agreement. Then only there is some common thing that we can attribute to at the group level. Okay, so keep this in mind: composition and compilation. And if what is important is RWG should not be computed for compilation processes. This is a typo. I will correct it. This is when you have, what I'm trying to say is when the group level construct changes meaning as compared to the individual level, then RWG is not necessary. ICC2 should always be computed to show that the groups have reliably different mean values on the construct of interest. Okay, that is what the recommendation is. Okay, with this, let us go to the R script. Okay, and I will show you how to compute RWG. Okay, ICC1, ICC2 we have seen. RWG, so let's look at line number 23. There is no corresponding command available in SPSS, so we will have to learn how to do it in R. Let's look at data BHR 2000. This is also I have taken from this, if you see 3.2 on page number 13 of Please. This is the example that he gives. Okay, he says that the name function identifies 14 variables. The first one is group, which is the grouping identifier. The variables in columns 2 to through 12 are individual responses on 11 items that make up a leadership scale. R's represent individuals' report of work hours. Relic represent individuals' report of the degree to which religion is a useful coping mechanism. Okay, and there are 5,400 observations. There are 99 unique platoons in this. Okay, so let's do this. Data BHR we have done. Names, we get all of this, right? We get this. It says GRP, and then there are 11 items 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 hours worked, and religion as a coping mechanism. This is what I have written here. Now, how do we compute RWG? I have written here RWG, RWGJ, and R star WG. Let me explain what these are. Now, if I want to show whether people agree on a particular variable, okay, so this is uni item, okay, one item construct, HRS is one item. So we say RWG, the command is RWG, and then what is the variable for which you want to compute? Relic. What is the grouping variable? It is GRP, and then we have to put in key in this value, which is random variance, which computes the variance for a rectangular distribution, uh, uh, which is essentially computed by a square minus 1 divided by 12, where a represents number of response options associated with the scale anchor. So here religion uh, was measured, relic was measured on a Likert scale of 1 to 5. So what is a to the power 2 minus 1 whole divided by 12? It is 5 square minus 1 divided by 12, which is equal to 25 minus 1 by 12, which is equal to 2. That is why we key in the random variance as 2 here. Okay, so I do this and then I do summary, and you see it says we look at the RWG and we look at the mean. The mean RWG is 0.18, and we said RWG should be greater than 0.70, but we also know that religion and at the individual level, and when you try to aggregate it to the group level, they will mean very different things. Okay, religion for the individual and religion at the group level may have very different meanings. So RWG may not be a useful uh, index to show before we aggregate. Okay, that is up to you how you want to theorize your construct, etc. Now there is also a very useful command which is rwg.sim, which says if I have on an average a group size of 40 and a scale on Likert scale of response option 5, okay, I want to see what would be the 95% confidence interval for RWG. Okay, where so essentially this command gives you a threshold to compare. If your RWG that you are getting is above the threshold that we get from rwg.sim, then we can say my RWG is fine. Otherwise, you have a problem and you may not be able to aggregate it. So let's look at this. Now see what is the output. It says group size is 40, number of response options was 5, number of items is 1. There's only one item, religion, right? And what did we say? We say, what did we write here? We said the rwg.95 was 0.23. And what is it that we are getting? That at 95%, if your RWG was greater than 0.23, you can say I can aggregate. There is no problem in aggregation, right? So this is if you are getting a lower RWG, you can run this command to see if you are getting more than the threshold suggested by this, and you can write it. Otherwise, you have a uh, you cannot kind of uh, uh, aggregate, or you theorize that I don't need to show agreement because religion is compilational in nature. uh, when I aggregate, it has a very different meaning than what is it at the group level, at the individual level. Similarly, if I have, yes, and this quantile is telling you what are the thresholds at 90%, at 95%, 99%. These are the threshold RWG values. Then if you want to do it for a group of if you have a multi-item, not just one item, but multi-item, then the command is rwg.j. rwg.j. So you say bhr 2000 2 to 12. Okay, so we have the 11 items of the leadership construct. Okay, group, and then the random variance is equal to 2. When I run this, and now when I do report, you see you get your RWG as 0.88, which is showing that there is a high inter rater agreement, and therefore it is okay to aggregate all of these and bring them to the group level. And then rwg dot j dot out, this is the same output. Okay, it says g size 15, on an average number of items are 7, number of responses are 5, and okay, so if I run this, it is computing and it is telling me that if you have 7 items, okay, if you have anything above 0.53, you are good. Your RWG should be. So here we can actually change it to 11 also and see what is it that we are getting. And for 11 items, anything above 0.60 should be good, right? So this varies as a function of group size. If you have on an average larger groups, okay, let's say the group size is 30, then you will have smaller thresholds. You see the threshold has gone to, but if you have smaller group sizes, so let's say on an average you have a group size of 5, and then you will have larger thresholds. Okay, you see it is 0.77. So it varies as it is a function of group size. For smaller groups, you need larger agreement. For larger groups, smaller agreement is also fine. Okay, so that is what is being shown here. So on an average, yeah, this is what. So you can try out, you can change these repetitions if I say, but that should not make a too much of a difference. Let me see if I change it to, okay, and now I say, yeah, and about the same. It's just okay. Now there are a few criticisms of RWG which I should highlight. It says the RWG, it assumes a rectangular distribution, which says that it's a unit level distribution. That means every option on a Likert scale 1 to 5 is equally likely. That is why you have this variance, random variance. In order to account for or remove this assumption, people say that you should have uh, alternate RWG models. So there are two models that are usually reported, RWG.J.Lindell, which uses the formula, okay. So it says R star WG models the average variance of the items into the numerator in lieu of using the, so it uses RWG is equal to 1 minus observed group variance divided by expected random variance. So this is the random variance, and then if I report this, now you see if you do this, then your RWG is actually much smaller than what we were getting, which was 0.8876. So it says that, well, this assumption is not right. It should actually be, the correct RWG is 0.4289. That is what is written here. So you can read this, and he says, note that Linden and colleagues have raised concerns about the mathematical underpinnings of RWG-J formula, that they note that this formula is based upon Spearman-Brown reliability estimator. Generalizability theory provides a basis to believe that our reliability should increase as the number of measurement increase. Okay, to believe that the applies to measures, that is, there may be no reason to believe that agreement should increase as the number of measurement on a scale increase. To address this potential concern with RWGJ, Linden and colleagues have proposed this formula. It is calculated by substituting average variance of the items in the scale into the numerator of RWG formula in lieu of the actual formula 1 minus observed group variance minus. Linden and colleague also recommend against truncating the observed group variance value so that it matches the expected random variance in case where the observed variance is larger than expected variance. Okay, so they have given this formula. You can try this out in case you are getting a better. And so they say the average R star WGJ of 0.43 is considerably lower than the average RWGJ value. However, let me also tell you that a lot of people don't really understand these differences, and in papers, in my experience, people generally report RWGJ values. So in case you are getting reasonable RWGJ value, you may go ahead and report that also. Then there is AWG index, which actually makes no assumption of random variance. It just says what is the item and then what is the grouping variable. Okay, and so you can use that also as another index which I have reported. And you see awg.lead, awg2 colon 12, and if you see this value is 0.4125, which is again close to what rwg.j.lindell is reporting. So I will stop at this point about the RWG indices in case you want to. So you can try out these 3-4 different functions, and in case you are getting whichever is giving you better results, you can go ahead and report that. People generally are okay with these indices. Then we have already seen how to compute ICC1 and ICC2. So if you want to compute ICC1 and 2 for a particular uh, variable, okay, this is how you compute it. You simply say HRS and as dot factor group. So you should always write as dot factor and then what is the grouping variable, and then you write your ICC1 and ICC2. So this says that your HRS varies 17% across groups, and the mean group means can be reliably differentiated, right, across groups. So that is good. That is all that we want. Our ICC2 should be greater than 0.70, ICC1 doesn't matter, and RWG should be greater than 0.70 if you want to aggregate, and if you want to show, first of all, if you want to prove that these indices are necessary, then only you should report these, otherwise they are not even necessary. As I demonstrated, if your level 2 variable has a very different meaning from level 1 variable, then there is no need to even talk about RWG. Simply just report ICC2 and go ahead and work. Okay, and the last, so just to report again, remind you all of this, that RWG and ICC2 are not very easily computed in SPSS. So you may need to keep in mind these few lines of code that I have written in this additional commands script from line number 32 to line number 65. These are some commands that you should keep in mind and you should learn how to run. Then mean centering, okay. There are two ways of centering the variables. One, and this is going to be useful when we do multi-level mediation models. There are two ways of finding the mean in any data, okay, in any variable. This is called as mean centering. Let me open the whiteboard. In multi-level models, means, so this idea is called as mean centering. of variables. Now, if you have, for example, let's say the example that we had, HRSIJ, okay, it had certain values. So we had group 1, we had group 2, and we had group 99, right? In our data, we had this. Now, one way to mean center any variable is we can take the mean. So we let's call it as HRS mean center. We can simply say HRS ij minus its mean, overall mean, right? I take the mean of HRS for all, say, 7,000 observations. Okay, the first step is I take the mean of HRS, okay, for 7,000 or all observations, and then simply subtract it. So we say HRS mean center is HRS ij minus its mean. This is called as, in multi-level terminology, this is called as grand mean centering.
Sir, could you please repeat this? I understood the first step. Second one.
Which is we what did we do? We took the grand. So what did we do? We took the grand mean, correct, which was the mean for all observations, right? And this is, we say this is HRS bar. This is the overall mean of this variable for entire observations, correct? And then what did we do? We subtracted all the entries that we had, HRS ij, for all entries we subtracted the grand mean. So what have we done? We have actually centered this data. So it is called as mean centering. Subtracting. What is mean centering? Nothing but subtracting the mean from the observations. So what is the observation? It is HRSIJ. This is what people have reported. From each of these observation, you subtract its grand mean. This is what we call as mean centering, right? Remember, in when we used to standardize a variable, we used to say standardized x is nothing but x minus x bar whole divided by standard deviation of x. This part is called as mean centering. Centering the variable around its mean and then dividing it by its standard deviation. Is this okay?
Yes, sir. Thank you.
Yeah. Now this is grand mean centering. The other way to do now in when we were doing one level modeling, we only had grand mean, right? We had, but here in multi-level, you have also another mean that you know, and that is group mean, GHRSJ. It varies per group, right? So the other way of centering variables that are possible is what we call as group mean centering. Group mean centering. What is group mean centering? Group mean centering is you compute the step one is you compute group means, which will be same for one group but different for, so let's say you have 10 entries or 4 entries. So let's say you have 7 7 7 7. This will be same within a group but will be different for another group. 8 8 8. Then you will have 10 10 10 10, whatever, 6 6 6 6 6. So this is group mean. Group mean. This is group mean. And each group is different, right? But if I take the overall mean, the grand mean could be something else. Grand mean could be, say, 7.5, and this is for entire set of observations. Is this okay? Any questions? So group mean centering says that you first compute the group means, and then what do is you say g dot, right, which is g dot hrs, and then you compute the within group hrs, or you can say mean centered. Group mean centered is nothing but hrs ij minus g dot hrs j. This is called as within group mean centered. That is why I have written w. Within group mean centered. So it is centered within a group, right? It is centered within a, it is centered with respect to, within means with respect to groups mean. Okay, you can say centered within a group or with respect to groups. So in multi-level data, when we were doing one level data, there was only one way of centering a data, which was grand mean centering. This was when we had one level data. But in multi-level data, you have two ways of centering a data: grand mean centering and group mean centering. Okay, so this is for your understanding. And now when I come to multi-level mediation model, I will tell you where this is needed. But let me first demonstrate how to do it in R. Okay, and then we can see how to do it in uh, SPSS also. Okay, so I am using a SPSS data file, uh, which is I think the same SPSS. So let's look at yeah, library foreign, line number 73. And if you run this, it will ask you which data file. So let's say I want to read this data file bh 1966. Okay, 1996. This is the data file that I have read, right? So it asked me which data file. This command will open a pop-up window. Which is the data file you want to read? So I say bh1996.sab. So it will read this data file and store it in bh1996.spss. Now let's say I want to do centering for leadership. So what do? I show you how to do grand mean centering, which is very simple, very simple. You simply say grand mean centered. Okay, uh, this is g dot lead. I have used this notation here, is nothing but lead minus its overall mean of entire leadership. So in one sentence, you get the g dot lead. So what have we done? We have subtracted from this entity the grand mean. Okay, so let me show you what is the grand mean. Let us run this. So the grand mean is 2.890665. So from 3.181818, I subtract the grand mean. So from 3.181818 minus 2.890665, the grand mean, you get 0.291153. This is the grand mean centered variable. Now the second is, you see, now you will see the use of the aggregate and the merge function. So I create an use the aggregate command, and I say, what is the variable I want to aggregate? I want to use lead. What is the listing variable? It is the group variable. It is the grouping identifier, group identifier. And what is the function I want to perform? I want to take the mean. So I do this, and I save the output in temp. If I look at temp, okay, if I look at temp, you see it gets group. And how many variables? There are 99. So there are 99 groups and there are 99 means. Okay, these are the group means for 99 groups. I change the names and I say give the names as group and group mean leadership. So if I do this and I go to temp now, you see it says group and group mean for leadership, right? Now what do? I merge my dataset 1996.spss and temp, and both of them have the same grouping identifier. You see group is here and group is also here. So what do? I run this command 84, sorry, and now you see in your 1996.spss data frame, you have an additional variable group.mean.lead, which is going to be the same repeated. This is the same group mean for all the first 70 entities. You will see for all first 74, row number 74 up till group 1, the mean is 2.929. Then from 75, there is another mean 2.48554. So what have we done now? We have taken the group mean. And now what is the within lead? It is very simple. Now you have to just subtract the corresponding leadership value with its group mean. So if I run this now and I go to my data set, you see now 3.181818 minus the group mean. So let us do it again. 3.181818 minus 2.929150. So it gives you 0.252668. Similarly, 3 minus 2.929, you get this, and so on. So this is the grand mean centered from the overall mean and the within group mean centered, right? This is called as grand mean centering and group mean centering. And then I have shown you again, you can try it at your home. Well-being means the same, well-being and HLS. Okay, so these are some additional commands. First I showed you how to use the merge and aggregate, then RWG, and then mean centering the data. This is something that you should keep handy when you are working on your multi-level data sets. Now let us come to the last thing on multi-level which I want to talk about, which is multi-level mediation. Any questions anybody has here? Okay, let us go to multi-level mediation models now. Let me open my whiteboard. And so we have, what have we learned up till now in multi-level models? We have learned how to write the syntax for multi-level models and how to do moderation testing, right? Now, and also learned how to do it in both R and SPSS. Both are good softwares, but R can help you compute ICC 1, 2, and RWG very easily. Okay, that's the added benefit. Now let's come to multi-level mediation. Now I will talk about two kinds of models, okay, in multi-level mediation. Now uh, we will use the same data of leadership, hours worked, and so what is the model that we looked at? We had looked at G dot HRS, right? And we had said that we had HRS IJ, G dot HRSJ, well-being IJ. This was the relationship, and we had lead IJ, okay, and this was the moderation model that we had learned. Okay, good. So this is completed, done and dusted. Now let's say, and there was obviously, this was the level representation. Now let's say we have a model which says group level leadership, okay, leadership at the team level, okay, and so there are, this is level 2 and level 1. So this is group level leadership, that means leadership of the platoon actually impacts the hours worked, and hours worked impacts the well-being of the individual. So what we are saying? We are saying that group level leadership or the platoon leadership, okay, which is actually the right thing, that you have one leader for a platoon. So leadership is actually a level 2 variable. So I am saying leadership at the platoon of the platoon impacts my well-being, right? So there should be a positive relationship. I am also saying that leadership of the platoon, if you have a positive leader, then he or she will actually reduce my workload. So it will have a negative relationship with the number of hours I put in. So a good leader would actually, a positive leader would be more cognizant about the number of hours a cadet is putting in. And therefore, if you have, and we have already seen that more number of hours worked will have a negative relationship with well-being. So we are saying that leaders have a positive relationship with well-being, and HRSIJ mediates mediates the G you can say simply leadership to well-being relationship. Is this okay? This kind of mediation models are called as 2-1-1 mediation models. Okay, 2-1-1 mediation model. Why? Because your X is a level 2 variable, the mediator is a level 1 variable, and your Y is also a level 1 variable. Is this okay? Any questions here? The notation and the representation? You can have, so this is our first kind of mediation model that we will learn. Model 1. You can also have another kind of mediation model. Let's call it as model number 2. Okay, where we argue that G dot lead at the group level will have a negative influence on, or will have a negative relationship on the number of hours a platoon puts in. And you have well-being Ij, and we can say we continue to have HRS Ij. So we say that leadership has a direct effect on well-being of the cadet, and leaders can have a negative relationship so with the number of hours the group as a whole puts in. That means positive leaders will also manage the number of hours a group puts in. So we can also have this kind. And if you have a platoon which is working more overall, then the well-being is negative. So you can say that leadership also has a mediation via G dot HRS. And this is called as what I call as, or what is called as 2-1 mediation model. Right? There is a possibility that your X, because now your X is at L2, your M is also at L2, and your Y is at L1. So we will learn, these are the two models that are typically done, and they are the models that are possible when we do multi-level mediation analysis, and that is what I am going to teach you now. Any questions on how we have done this, the notation, etc.? Okay. All right, so now what we will do is, let us see how do we test this model now. How do we write the mathematical formulation of these models, and how do we actually test it? We will use the same data that we have been working, the platoon data of well-being, leadership, and these examples are not given in the Blease document. These I have created on my own, and the R script I have shared with you. So let us look at the first mediation model 1. Okay, and the writing is very simple, the formulation is very simple. Okay, and if you understand mediation, uh, we will uh, do it. So let me also, before we begin, let me also just revise the fundamentals of mediation very quickly. So if you remember, we used to draw our mediation models like this: x to m to y. We said this is A, this is B, this is C dash. Okay, and so our indirect effect is given as A into B, and the hypothesis test is that this is we say this is A predicted, B predicted, C dash predicted. So a hypothesis is A into B is equal to 0, H1 A into B is not equal to 0. How do we test? We used to compute Sobel's T, which is given as A predicted, B predicted divided by standard error of AB. And standard error of AB is given as A square multiplied with SE B square plus B square multiplied with SE A square plus SE A square multiplied with SE B square, right? And we said if our p value is less than alpha, we reject H naught and we say our mediation is significant because our indirect effect is this okay, right? Any questions here? Feel free to stop me. Okay, this is the mediation uh, kind of very quick understanding of how we used to do one level mediations, right? Now let's look at our mediation model 1, where we said that our G dot lead J impacts the level 1 predictor, and the level 1 predictor impacts the level 1 outcome. And this is L2, this is L1, right? So what we have to do now is we have to start writing the equations very simply, okay? And we will see what do we get. So let us write the first set of equations, set 1, okay? And what is the set 1? I am saying well-being, or I am modeling this path directly without any mediator in between. So I am saying what is this path between well-being to ij, right? So if you remember, when we used to test, we used to say, is there actually a relationship between x to y? That is, without the mediator, is there a relationship, right? Then we go forward. So we are going to write this relationship. We are going to write the equations for this relationship. So what do we say? Well-being ij is equal to beta 0 j, and at the L1 level there is no predictor at the moment because this is L2, right? So just to help you understand what I am doing, we will draw the multi-level kind of a diagram. So what am I testing? I am testing this equation, right? This is the model that we are testing. So now when I write, you must understand that there is no L1 predictor at the moment. So that is why I wrote beta 0j plus Rij. And then what I say beta 0j is equal to gamma 00, and this has a L2 predictor which is gamma 01 G dot lead J plus U0. So what do I get? Well-being J Ij is equal to gamma 00 plus gamma 01 G dot lead plus U0j plus Rij. Is this okay? Now we must understand one thing, that now in mediation we have to perform multiple sets of testing. But this notation of beta 0j, gamma 00, gamma 01, U0, Rij is essentially unique to multi-level, and every time I write these different set of equations, I will be using these beta 0j, Rij. So therefore, there is a subscript, so that we must understand that this beta 0j is associated with this first set of equations. So we say this is beta 0j associated with set 1, gamma 00 set 1, gamma 01 for set 1, and u0j for set 1. So well-being, we can say this is gamma 00 for set 1, for set 1 equations, u0j for set 1 equation, Rij for set 1 equation. This is notation and we must understand this. Now, what is going to be, so this is my testing of the first direct path without the mediator between my x to y. Now, what is the second set of equations that I am going to write? I am going to test the relationship between x to mediator. So I am going to test whether this is related to HRS IJ, right? This is what we used to do in mediation. This is what? This is the relationship between x to the mediator. Correct? That is what we want to do. So what do we write? We say HRS Ij now is equal to beta 0j, and now again you see there is no L1 predictor for HRS, so we say beta 0j plus Rij, and beta 0j is given by very simply gamma 00 and gamma 01 G dot lead J plus U0, and these are all associated with set 2. Now you should appreciate that beta 0j is a unique notation, and it is going to be repeated every time in all the set of equations, and therefore I have to differentiate between this beta 0j from this beta 0j, right? So therefore I add the superscript 1 because this is associated with set 1. This is associated with set 2. So beta 0 j 2 is equal to gamma 0 0 2, gamma 0 0 1 1, and u 0. So when I combine, what do I get? I get HRS Ij is equal to gamma 0 0 plus gamma 0 1 G dot lead J plus U 0 J plus R I J. And this is all associated at set 2. Okay. And now comes the third set, which is what we used to do in mediation, where we are going to test this entire model, right? This entire model. Set number 3 is this model where you are saying that x to m to y, and you have a path from x to m, right? So you have a direct path and you have an indirect path from, or let me draw it better, just like we used to draw mediation model. We will say it is, where should I, yeah, I think this is better. So let me write the equation here. So I say set 3 is x to m to y, and in our case this is the model, right, for which we want to write the equations. So what is it that we are going to do? We are going to write now the equation. Actually the set 3 is only going to be x and m. So y, so we say x, yeah, this is the set 3 because x to m we have already tested. Okay, so what we are going to say, we are going to do well-being Ij is equal to beta 0 j. Now you have a L1 predictor, so I am going to write HRS Ij plus Rij. Beta 0 j is equal to gamma 0 0 plus gamma 0 1 G dot lead J plus U0 J, and beta 1 J is simply your gamma 1 0. So in this case, actually, let me not confuse. In this case, you will have mediator here and x here, and x is going to be g dot lead, and you will have your mediator as HRS Ij, and you will have your, right. So we have written the equation, we have got g. So and this is set number 3, set number set 3. Now when we combine this, what do we get? Ij is equal to gamma 0 0, gamma 0 1, gamma 10 HRS ij plus U0j plus Rij, and they are all at L3 at for set number 3. Right? Now if you look at these three set of equations, okay, set 1, set 2, and set number 3, right? This is what we have got. What is our hypothesis? So we will run our model 3 times. We will estimate set 1 equation, set 2, and set 3. Okay, and what is our h naught? Our h naught is a into b is equal to 0, and h1 a into b is not equal to 0. What is a? A was the path from x to m, right? A is x to m, and b is m to y. So can anybody tell what is x to m in this model? If you see this,
Gamma.
what is x? X was g dot lead,
Yes.
and what is m?
HRSIJ.
HRS. So can anybody tell what is a here? The coefficient a?
Gamma 01.
Gamma 01 are many in this set of equations. So
Actually, gamma 01 2.
very good, excellent. This is the coefficient. This is the mediation equation, mediation and x equation. You see, I have written x to m. So what is a? A is this coefficient, the coefficient associated with this term. So what is a? A is going to be gamma 01 subscript 2. When we would run our second set of equations, then the gamma that we get there, gamma 01, that is our A. Now tell me what is B, M to Y? M to Y, look at the diagram. M to Y,
State 1 go. Nine.
yeah?
Is HRSIJ
HRS
to WB to well-being IJ.
very good, very good. So what is the coefficient?
Gamma 103. Gamma 103.
Gamma 103. Any other? It is going to be the term associated with the mediator in this model, correct? So what is it that we get? It is going to be gamma 103. So what is going to be our interaction or indirect effect? It is going to be gamma 01 multiplied with 2 whole multiplied with gamma 10. Okay, we will also get the standard error of A, we will get standard error of B. We will plug this into the formula of Sobel T, which is A into B divided by standard error of AB, and we will get whether our mediation is significant or not. Is this making sense? Any question? So what did we do? We did first, we just tested whether there is a significant effect or not between x and y. Then we tested x to m. We wrote this set of equation, and then we tested this set of equation. Now if you do this, this is also enough. But the paper that I shared with you, Zhang et al., what they have mentioned is that when there is a L1 to L1 relationship here, what is it that we were interested in actually examining? We were interested in examining this L2 relationship. We were, let me draw, open a whiteboard. So this is, so they mention that what we were interested in testing is basically you were interested in estimating this equation, right? Well-being. This was your direct effect, that you wanted to check whether is mediated through this L1 variable. Now the problem with this L1 mediator is that this L1 mediator is not actually accounting for how the group level or between group variation happens for this leadership to well-being, because you see this mediator is only at L1. So how will it account for how the level 2 relationship mediates level 2 relationship between leadership and well-being is mediated by HRS, because this by effect is only L1. And so this paper actually says that if you do what we did in the previous uh, thing, where in set 1 you regress x to y, then in set 2 you regressed x to m, okay, and in set 3 you regressed x to y and m to y. This actually is incorrect because it does not account for L2 relationship being mediated, as the mediator is only as mediator is at level 1. Because you see this mediator, this is in principle a level 2 relationship. This is a level 2 relationship between level, how a level 2 variable is impacting a level 1 variable. But how can a variable which is at L1 talk about how a level 2 relationship is getting mediated? So the only catch, so this paper, Zhang et al., which I shared with you all also today, is they suggest the following. what is it that they suggest? They say that if you in, and this is only specific for 211 model, there is no such problem in 221 model. In a 211 model, what you should do is you bring your lead and you have your well-being, which is all right at level 1 and lead is at level 2. Okay, and then you bring in your HRS IJ. So what they say is, rather than using HRS IJ, you actually use within group mean centered. So you, what is it that means? You actually use HRS IJ minus G dot HRS J, right? This is what we had written is the definition of within group mean centered. And you regress well-being on this, and you do this path also. And then in order to account for how this variable mediates the level 2 relationship, you bring in G dot HRS at level 2 group mean, and you also regress well-being on G dot HRS. So it says this is called as, it is written as centered within context with the mean reintroduced at level 2. In the paper they define it as centered within context with mean reintroduced at level 2. This is what the full form of this is. So you do the normal regression, but you, in the final run, you also regress well-being on G dot HRS. Okay, so let us do it and see what is it that they are trying to tell us. So everything else remains the same. Set 1 remained the same. Okay, where they said that you regress L lead, J, and well-being, IJ. Okay, what will be the equation? It will be well-being IJ is equal to beta 0j plus R IJ, and beta 0j is equal to gamma 00 plus gamma 01 plus U0, and these are all associated with set 1 now. And so you will get well-being IJ is equal to gamma 00, gamma 01 plus U0j plus right. This is the set 1 now. Then what we do is in set 2, Okay, we regress the G dot lead J to HRS IJ. The normal, this was again just a normal regression because we want to test the path from X to M, right? So what do? We write the uh, we uh, we write the equation once again, which is going to be, just a minute. Okay, so we write the equation once again, which is HRS IJ is equal to plus U0, and they are all associated with set 2 now. So your HRSIJ becomes gamma 00 plus gamma 01 G dot lead J plus U0J plus RI J, and they are all associated with L2. Now these two sets are common. They are common across. They are common across the two runs, either CWC or the original model. Okay, they are the same. That is why in the paper, if you see, they call it as set 1 and set 2. The last set, instead of calling set 3, they write it as set 4. I could have written set 3, but just to be consistent with their terminology, because set 3 they are calling the previous model as the equation. Let me just write the equation and then I will show you why. So set 3, because the previous equation was there. In set 4, what we are going to model now, we are going to model this kind of a equation. Well-being IJ, and then W dot HRS IJ and G dot HRSJ. This is the set 4 equation. So what it will be? Very simply, it will be well-being Ij is equal to beta 0j plus beta 1j W dot HRS IJ plus RIJ, and you will say beta 0j is now gamma 00 plus gamma 01 G dot lead J plus gamma 02 G dot HRS J plus U0 J, and beta 1j will be a constant because there is no random slope. We are modeling mediation here, so we call all of these are associated with set 4. So when we combine, what do we get? We get well-being ij is equal to gamma 0 0, gamma 0 1, gamma 0 2, g dot hrs j plus gamma 1 0, w dot hrs ij plus u0j plus ri. Right? So what is A now? Now these are our equations. So they say, again looking at our H naught, A into B is equal to, so this is the revised set of equations, and A into B not equal to 0. So he says in the paper, they say A is equal to x to m. Now what will be x to m? Anybody? X to m, G lead, it is this model, G lead to HRSIJ. What will be x to m? It will still be this. There is no change here. So it will continue to be the coefficient of
Gamma 0.
gamma 0 1 that we will get in our second run, which is set number 2. And then what is B? B, they say, is actually this part. Okay, B, they say, is you should look at what do you get after you have introduced w dot hrs. What do you get the coefficient of the path from the group mean of hrs, because that is accounting for the level 2 relationship. So they call this as B and this as A. So in multi-level, it will be, we can say it is M dot J. This is how they write M dot J to Y. This is X J to M I J. Okay. And M dot J, which is equal to, in this case, what will it be?
Gamma 0 to 4.
Gamma 0 to 4. Excellent. It will be gamma 0 to 4. Gamma 0 to 4. Now we know the standard errors in S, and so what will it be? Gamma 0 1 2 multiplied with gamma 0 to 4 whole divided by standard error of AB, and you will plug this into your coefficient in your there are online calculators. We will plug this into the thing and we will get the result. That is all that we have to keep in mind. Now let me take you to the paper, because that is important to look at. The paper that I had shared with you, all of you, Zhang et al. Okay, testing multi-level mediation using hierarchical linear models. So let me take you, yes, this is what they have said. Okay, we know how do we test. We say A into B. So the test of significance is you calculate Sobel's test, A into B divided by standard error, which is A square sigma B square, B square sigma A square, and sigma square A multiplied with sigma square B. Now there are two kinds of models, xj to mij to yij. This is called as 2-1-1 model. And then you have 2-2-1 model, okay, which is X to MJ, sorry, and then YIJ. And there is also 1-1-1 model, which I am not going to discuss, which is everything at level 1, and then you just want to model the multi-level thing. You can read it, but I am going to discuss 2-1-1 and 2-2-1 models. And they say that indicates that grand mean centered HLM model can produce confounded estimates of mediation effects. Now, if you look at this, they say available procedures. Let me show you these equations. 2-1-1 model, grand mean centering or no centering, right? We miss grand mean center or doesn't matter. If you look at the equations, Yij is equal to beta 0j plus Rij. This is set 1. You'll see the notations that I am using are what are prescribed. And beta 0j is equal to gamma 00 plus gamma 01 xj plus u0j. This is simple xj to Yij. Then xj to Mij, which is Mij, and then beta 00 is again gamma 0, gamma 01, xj and u0j. And then level 3, where we had both L1, so you wrote beta 0j plus beta 1j Mij plus Rij, right? This was, for us, it was HRSIJ and YIJ is WB. And then we said beta 0j is gamma 00 plus G dot lead and U0j, and beta 1j is equal to gamma 10. There is no random slope. So what is the mediation effect? You get X, this term A, this is A, and what is B? It is the path from M, the mediator, which is gamma 10. So that is what they have written. This is the mediation effect, A into B. Gamma 012 multiplied with gamma 103. But now they are saying CWCM. Let me also tell you what is CWCM. You can read it when you go back. CWCM is, you see, it says comparing grand mean centered with CWCM. Okay, yeah, specifically explodes centered within context with reintroduction of the subtracted means at level 2. This is what CWCM means, right? Centered within context with mean reintroduced at level 2. So let us go back to the equation. Yeah. So L1, this set 1 and set 2 equations are the same. And now what they say is Yij is equal to beta 0j, beta 1j, and this is what I have written W dot HRS. This is Mij minus the group mean, right? So we bring that at L1, and at L2, what do? We say gamma 00, gamma 01 xj, and we bring in the mean again. You see, this mean has come back, which we subtracted at L1. This was subtracted at L1, okay, is now reintroduced at L2. And beta 1j continues. So what is going to be our indirect effect now? Our indirect effect is going to be gamma 01 times 2 and the coefficient associated with the mean which was introduced at L2. So you see it is gamma 01 2 multiplied with gamma 02 4. That is what. And then once we get this, we will test the significance of using Sobel's t-test. Is this okay? Any questions here?
Sir, here Hello.
Yes, go ahead.
Yeah, sir. This is a 2-1-1 model. So mediation must be in the first level. So a mediator, and in that case, it is an individual level. It's not a group. Maybe. So because of that, here we are talking about
Yes,
Mij minus Mj.
because we are talking, so the issue is we are talking about a L1 variable mediating a L2 relationship, and that L1 variable is not there at L2 in this kind of, in the first
Yes, yes,
kind of modeling, and that is why it gives us a wrong coefficient. So we need to explicitly bring its effect at L2 and then measure it
okay,
and check its impact, because we are talking about a L2 to L1 relationship being mediated, and L1 is not at L2, so how can it mediate
correct, correct.
a relationship that where it is not? What is available at L2 is its group mean, so you should use group mean of L2 rather than L1 mediator in your while you are testing the mediation. Is that okay?
Yes, sir. And the coefficient of beta 1j in level 4, that Mij
That
minus
this is this one,
Mij
this one,
beta
yes.
1j beta 1j level 1
Beta
level 1.
1j is gamma 104, right? Here.
Yeah, here it is that you have highlighted M1 Mij minus M dot
Dot
J.
J. Yeah.
Yeah. So that is actually the normal centering
That
there,
is the
normal mean centering.
no. This is group mean centering, right?
Group mean centering, but again, M is at the level 1, so it is simply X minus X bar.
X minus X bar, but X bar of the group, not
X bar of the
group. This is M dot J.
X bar of the group, but group, there is no group na at L1.
Array L1, you see L1, it is L1, but they are now they have been divided into groups, right? Imagine your platoon. You have well-being and you have hours worked, right?
Yes, yes,
What is M? M is hours worked, HRS IJ,
yes,
right?
yes, yes,
Now, as HRS IJ has been divided into groups, right? So you have, if we did not have multi-level, we would have overall HRSIJ, all HRSIJ.
yes, yes, yes,
But we
yes,
now know that these HRSIJ are for group 1, these HRSIJ are for group 2, another set of HRSIJ are for group 3, and so on.
okay,
So
okay.
you can calculate the mean of HRSIJ for each group, right? That is
Yes, yes, yes,
what HRS dot J. That is what we are saying is the mean of the group
yes, yes, understood.
of HRS. And so you have centered HRSIJ on the
Group mean.
the group mean, the mean of the group to which they belong specifically, right? And you
Yes, sir.
reintroduce that group mean at level 2. This is what L2 is happening here.
Yes,
Is that making sense?
yes. Thank you.
Okay, so let me demonstrate how do you do this in your how we do this in our R. Okay, so I will show you how to do this in R. So let's do data. Okay, and we have if you click at BH, you get all of this. So I will first clean this data. So you see I have dropped all this 3 4 g.co has w.co has. I'm removing this, and that is what I have written here. Drop all the columns -3 -4 -6 7 -9 -10, and now if you see data, I have created a data frame called data, which is a clean data, which is GRP, cohesion, lead, HRS, and well-being. Just like you would have collected data from your survey, right? So you have leadership, you have hours worked, you have well-being. Right, now we do centering. So I'm showing you how to do grand mean centering. So I have written here leadership underscore mean centering, which is essentially grand mean centered, is data lead minus mean of the entire data set. Okay, then I show you how to do group mean centering, which is aggregate and data lead minus comma list, which we had seen aggregate command. This is the grouping variable, and compute the mean. So I do this, and then if I click on temp, you will see temp is where is temp? Let me open it. Temp is this, right? It has group means. So what do? I give them names, right? G.lead, and then I merge the data, and so you see you have the overall leadership mean centered, and you have the group level leadership. This G.lead is what we are going to use in our uh, uh, data, right? And I have also shown how do you do within group mean centering, which is lead minus its group mean. So you get w.lead. So I have shown you how to do leadership grand mean centering, then computing the group mean and the within group mean centering w.lead. We will not need w.lead and lead underscore MC. We will need the g.lead because that is going to be our x variable, if you see in our model. And the same thing for HRS. I have done grand mean centering, HRS MC, then computing the group mean here, okay, and then merge. So now if you see, you have HRS mean centered, grand mean centered, and I have computed the group average of HRS. We will need this in our step 4, and then the within group mean centering. So there is w.HRS. Now if we go to line number 42, okay, I have written 211 mediation, model 1, 211 mediation. What is the model? It is g.lead. Okay, this is the overall model that we want to test, which we have been talking about. So I write the set 1 equations, which is well-being is regressed on g.lead. So y is regressed on x. So random intercept model, straight away I write well-being is regressed on intercept plus g.lead, and random is equal to tilde 1 varies per group, right? This is the model that we were doing. That is, there is just gamma 0 0. So let us look at this equation. So we said yij is equal to gamma 0 0 plus gamma 0 1 xij plus u0j plus rij, right? So the fixed effect is 1 plus xj. So what is 1 plus xj? Xj for us is g.lead, and random is 1 is equal to tilde, it is random intercept, right? So I write this and I test, and you see, I see that there is a significant impact of leadership on well-being, 0.412, and it is highly significant. And so it may be interesting to test the mediation. So what do I do now? I write the set 2 equations. And now set 2 equation is HRS is regressed on G dot lead. So if you
So,
see, yes,
so in case if the impact is not significant, then what
we
is
still
the...
go ahead. We still go ahead.
Okay.
Yeah,
Okay.
you should
Thanks.
still go ahead.
Okay.
Okay. So what is our second? We are doing the mediator. So what is our mediator? HRSIJ, and that is again a random intercept model. And what is our X? It is G dot lead. So we are again going to write 1 plus G dot lead, right? And our random is equal to 1 per group. So this is what I have written very simply. Well-being is regressed, sorry, set 2 equation is HRS, the mediator. This is what I have written. Mediator is regressed on X. So HRS is regressed on 1 plus G dot lead, which is our X, and it is random intercept. Everything else is the same. So what do we get? We get this. So X to M, let me open my Excel. Okay. So what do we get? We get X to M, which is our A, is equal to minus 1.105, and standard error of A is equal to 0.253, right? This is what we have got. Now we have got X to M, we have got the coefficient as well as its standard error. Now I write the set 3 equations, and what do I say? Well-being is regressed on HRS and G dot lead, that is Y is regressed on mediator as well as X, that is this set 3 equation. So what do I say? Yij, that is well-being, is regressed on HRSIJ, and then beta 0j is equal to gamma 0 0 gamma 0 1 G dot lead j, and beta 1j is gamma 1 0. So our fixed effect is equal to gamma 0 0 plus, so 1 plus G dot lead plus HRS, and it is only random intercept. So you see, I have written well-being is regressed on, Y is regressed on 1, which is gamma 0 0, then gamma 0 1 G dot lead, and gamma 1 0, and it is random intercept only. That is why random is equal to tilde. So I write this, I run this, and I do summary, and now I have got the relationship from HRS to our well-being also. So if it was the normal, I have written M to X. This is my equation, this is B, and this is standard error of, right? This is what we need. We need A,
M to Y.
we need B, right? So what do we get? It is minus 0.051, and the standard error is 0.005. This was the, you can say this is what was the, I will say, normal practice. Now we have the Zhang et al. Step. Okay, Zhang et al. 2009 additional step.
Sir,
So
it is M to Y, no? M to Y.
yes, sorry,
Yeah.
M2Y, correct. Thank you. So it is M2Y. Absolutely. Thank you very much. Yes. So we have the additional step. Okay. And what is it? The additional step, you see, now very interestingly, what have I done? I have written, so we set 1, set 2 are the same. Let's go to set 4. I have written Yij is equal to, that is well-being, is regressed on beta 0j and beta 1j, and now this will be w.hrs. W.hrs, that is mean, the HRS minus its group mean, which is w.hrs. And beta 0j is gamma 00, gamma 01, and at gamma 02, what is it? G.hrs, that is the group mean, G.hrs. So it is gamma 00, gamma 01, G dot lead, gamma 02, G dot HRS, and gamma 10, W dot HRS. This is W dot HRS and this is G dot HRS, which we have already computed. I have prepared my data file. I have G dot HRS and I have W dot HRS. So I go to my equation and I say well-being is regressed on 1 plus G dot lead plus G dot HRS plus W dot HRS, and I say random is equal to tilde group. It is still 1. It is still random intercept. I run this and I get my summary. And now what is it I want to report? I want to report this coefficient, which is G dot HRS to my Y, which is this. So I report this and I say M dot J to Y, which is equal to B in this case, and this is minus 0.14142, and standard error of B is 0.017. Correct? Now you have many Sobel test calculator. So you can say Sobel T calculator. You can see I like this Christopher Preacher. So now you can conduct Sobel tests. So we input our values. Okay, our A is minus 1.105 minus 1.105. Standard error of A was 0.253. B is minus 0.142 and 0.142, and standard error of B was 0.017. Just calculate this and you see your Sobel T comes out to be Sobel's T is equal to 3.870 and P value is less than 0.001. If we key in this, we get, let's key in 0.051 and standard error is 0.005. We get significant here as well. So we get, for this we get Sobel's T as 4.015 and P value less than 0.001. So anyways, in this case, both ways we are getting significant. But if in your research you can report simply this, that this is your, after following all the steps being prescribed, I get significant mediation, and therefore I can conclude that my HRSIJ mediates the relationship between the leadership, the group level leadership, and well-being, and this is my 211 model. In 2-to-1 model, there is no problem. There is no need to do any such thing. If you have a 2-to-2 model, because your mediator is also at level 2. Here you see we did all this because we wanted to bring mediator at level 2. In 2-to-1 model, okay, I will do this. The equations we'll spend half an hour tomorrow. In 2-to-1 model, you see the mediator is already at level 2. So there is no confounding. So this one is very straightforward and easy. Okay, we will write three set of equations. We'll regress y on x, we'll regress x on x, m on x, and we'll regress y on both m and x. We'll compute a, we'll compute b, we'll put it in the Sobility calculator and get the results. The issue was in 2-1-1 because you have a L1 variable which is trying to mediate a L2 relationship, and therefore there is a reason to bring L1 variable at L2 also. Here the mediator is already at L2, so there is no problems with it. There is no confounding. There we will write only three equations. You see, this is going to be multi-level. This one is actually one level only because your m is also at level 2, x is also at level 2. So this is going to be one level equation only. And then we will write the simple L1, L2 equation for y regressed on both x and m. And we'll compute, we'll record their A and B, SE A and SE B. We'll plug in to these Sobel test calculator and we'll report whether the mediation is significant or not. Okay, so let us stop here. We have anyways exceeded and I think we have covered good ground. So I'll come and finish. You see the next set of equations here are 2-to-1 mediation, okay, and very simple three set of equations, and we'll finish this discussion and start with introduction to longitudinal models tomorrow. Any questions? Okay, I will upload the recordings. I will upload all the scripts, the Excel. Okay, go over them and try to sync in what we have covered. Thank you very much, and I'll see you tomorrow.
Thank you so much.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you.